In the last section, we looked at the frequency and compounding, and hopefully you recognize that we can no longer compare interest rates directly without the combination of the interest rate and the compounding period. So, as before, the rate will often tell us, that the banks and institutions will often tell us, is the simple or annual rate. Sometimes this is called the APR, or the annual percentage rate. They must also tell us something about the compounding rate, whether it's daily, weekly, monthly, semi-annual, annual, biannual. If you take a look at your, say, some bank statement or maybe a credit card statement, you'll notice that it will have language, especially in a credit card statement, that will give you the annual rate. And then it will say that it compounds daily, and it will give you a daily rate. When we want to compare different interest rates, but they have differing compounding periods, we need to calculate them in such a way that we can compare them directly, or we can factor in the different compounding periods. In the previous problem, we found that 8% compounded annually was equivalent, that with a $100 investment became 116.64. But when we compounded it semi-annually, we got another 37 cents. So 8% compounded annually is not the same as 8% compounded semi-annually. And then we went on to quarterly as well as monthly. The equivalent annual rate, or effective annual rate, expresses an interest rate that compounds more than once per year as an equivalent interest rate with annual compounding. This is the actual rate of growth being earned or paid per year when compounding is considered. This is sometimes called the APY, or annual percentage yield. We calculate the EAR, or effective rate, by 1 plus the simple rate as a fraction or as a decimal, divided by m, the number of compounding periods, and then raised to m. The EAR for annual compounding would be equal to the simple annual rate. Any other case where m is greater than 1, we would find that the EAR is more than the simple annual rate. So going back to the examples in section 7, the future value of $100 compounded annually is 116.64. The equivalent annual rate is 8%. When we went to semi-annual, we got a higher future value, and the equivalent annual rate is 8.16%. Now, another way to say this is I am indifferent between receiving 8.16% compounded annually or 8% compounded semi-annually. Both methods will get me to $116.98 for my $100 invested after 2 years. So let's take a look at a problem. Let's assume that we deposit $400 in a checking account. It pays 5% interest compounded monthly. What is the effective annual rate? Well, option 1 will compare it, we'll calculate it numerically. So you can see that we put in 0.05 representing the simple or nominal rate. We divide by 12, or monthly compounding. We raise to 12. And then we subtract by 1. And please note where the parentheses are. So the parentheses are around the 1 plus that periodic interest rate. So 5% compounded monthly is equivalent to 5.12% compounded annually. Now your calculator can do this. In the BA2 Plus, we'll be using the iConversion worksheet, which is found here above the 2 key. In the TIs, you'll find the same function, but it's called the EFF function in your financial functions. So we'll enter into that iConversion worksheet. Enter it again. And I'm going to clear work, or clear the functions. So in this problem, we have a 5% interest rate. I'm going to hit the down arrow key twice. And we already have 12 in there, but I'll enter it again. And it's compounded, the number of compounding periods per year is 12. So if we go back up to this EFF, or effective annual rate, and hit compute, we can see that 5% compounded semi-annually is equivalent to 5.1162, which is rounded to 5.12. Another way to look at this is assume that we deposited the $400 into a checking account that pays 5% compounded monthly. Let's calculate the future value, assuming that 5%. So I'm going to make sure my P/Y, or payments per year function, is set at 1. And I'm going to clear time value of money. So over 1 year, we would have 12 compounding periods, or 12 months. The periodic compounding period would be 5% divided by 12. That's the periodic rate, or the interest rate per month. We'll deposit $100 into this account and compute the future value. So we see we get $420.46. Now let's think of it a different way. Let's assume that the interest rate is not compounded monthly, but it's compounded annually. But we're going to put in the annual, or the EAR, the effective annual rate, which in my calculation was 5.1162. We put in our same $400 deposit, and we compute the future value. And we get essentially, maybe a little bit of rounding, but essentially the same answer. So that's why we can say that we are indifferent between 5.12% compounded annually or 5% compounded monthly.